Hello friends, this is Praveen and today we are going to solve the Burj Khalifa puzzle. So what does this puzzle states that how many coins you need to measure the height of the Burj Khalifa. So there is a tall building which is for in this scenario this is known as the Burj Khalifa. So now we have to find its height. So the height is unknown now. So what you will do or how many coins you will require to measure the height of the Burj Khalifa. So let's move to the solution. So what may you imagine to fulfill the height of this building? That is, first you can stack up these coins on this, but this would not be useful because you would require lots of coins and this would be practically impossible. And another way you could do is stack up these coins on its rim. So this would be similarly, it would require a less number of coins, but it would be similarly again impossible. And then another way you can do is flipping these coin. So you take a coin, flip this the number of times, and then the number of times, then multiply by the circumference, you will get this. But then flipping is for another height is also very impractical. So what would be the logical approach for solving these questions? So the correct answer is that is one coin. So we required only one coin for that. So how we required one coin? Here we required height. So you can, with height you don't pursue this yet, but we can call this as a distance also, the distance from the top of the building to the bottom of the building. So when we remember about distance, we know that distance is equals to speed with a triangular, that is dst. So now we know that the distance is equals to speed multiplied by time, and the time is equals to speed, that is distance divided by the speed, and the speed is equals to distance divided by time. And the another thing that comes is known as acceleration, because now if we take up a coin and we throw it, we can make this cover this distance, and so we have to require a time also. But now the speed here is not constant, because we know that gravity is acting and the gravity provides acceleration. That means per second, that is 9.8 meter of the speed is increased. So instead of now we cannot take the speed. So how we could measure? Then now we have provided with nothing. So how we can take this out? We can take this out. So first we require time. So how can you measure time? You can take a stopwatch from throw the coin and record it at a time. You would say that it is practically not possible to pursue the stopwatch for a bigger unit, that is bigger unit. So what you can do is take your one friend stand on the top and you on the bottom. And if you have a digital watch, that means you started when you throw the coin, and he would stop the watch when the coin would reach at the bottom. So let's take that the throwing time would be 8:20 and 00 seconds, and the reaching time would be 8:20 10. So the distance between this is 10 seconds. So it is 10 seconds. Now we have got the time. So now time, and that is this equals to time. Now we have to find out the value of the height, that means distance, and with the second equation of the motion we can take that distance traveled is equals to ut plus half at square. Here u stands for the initial velocity, t stands for the time, s stands for the distance, a stands for the acceleration, t stands for the time. Okay, so what is the inertial velocity? We can't see inertial velocity, which means the point we started throwing, the ball would be there, it would be 0. So 0 multiplied by 10 would be this equation. So we are getting for it height and plus. So half. Now acceleration. Acceleration due to gravity would be nothing but 9.8. So it would be multiplied by 9.8 multiplied by, now the time, that is 10. The square of 10 would be 100. So we get 100. So now we get this as the, when we would multiply it, we would get 980 and multiply by half plus, so when we will do 0 multiply by anything would be 0, which would equals to height. So now halving of this, when we do half, we will get as the 450 plus 40, that is 490. So the height of the this building is the 450. But we have take this is only an example. The actual height of the Burj Khalifa is 829.8. So let's consider how much time would a coin require to fall from here. So in which what we have given is the distance is given as 429.8. Let's take a simplificate by 320. So we have, and we know inertial velocity would be 0, and so we, that is ut plus half at square. So this could be cancelled out because the inertial distance would be 0, so we can ignore this. And now we are remaining with half at square. So half at, that means half multiplied by, that is 9.8 multiplied by time, that is t square. We can take this, so when it would go here, it would be multiplied by 2, that is multiplied by 2 by 1, and now we can take this multiplied by, that is divided by 9.8. So when you will simplify by it, you will get the answer which is nearest to 10. So the time would be is equals to 10, that means 10 seconds. So friends, if it would be the Burj Khalifa, then it would require the 13-second fall. Okay friends, I hope that this puzzle is clear to you, and at the last, thanks for watching.